to.
So I'm just going to...
So while you're transitioning, I'll give a very quick introduction.
It'll be under CyberGIS.
In the interest of time.
Yeah, go ahead.
Well, it's great pleasure
Do I need
to
to-
introduce
I think you can open it.
Dan Fei and Mohamed Ali. You already knew from yesterday's panel. And we're on the backyard of Microsoft, right? Here in Seattle, and I had personal pleasure running to Dan in the supercomputing circles. And I had also pleasure running to Mohamed in the spatial circles. And I understood they are in different circles in Microsoft. So the community meeting here, we brought the circles together and closed some loops. And it's a really great to have both of you to join us to share your insights. And the title's up. Thanks very much.
Great. Thank you.
So you will actually, just to clarify, that mic is transmitting to here,
Okay.
to the meeting audio.
Yep.
It really won't come out of this audio, so if you can project for the room.
Okay.
Speak louder.
It's unfortunate. I don't really...
No, that's okay. That's okay. So I need to project louder today. This is always a good opportunity to practice those presentation skills you've all learned. Hopefully my voice will last. I've been fighting a cold the last few days, so. So one of the things, when Xiaowen, and I want to thank Xiaowen and the other organizers for actually inviting us, allowing us to come and participate. I was at last year's All Hands in Illinois, really enjoyed it as well. And I wanted to also bring and have Mohamed participate as well because of some of the work he's been doing, which he'll talk about, which is in this area of how do we get information that's based on GIS type stuff and geographical type ones into the hands of what I say decision makers. And that could be policymakers, but it could also be the general public. How do we get into the hands of people, consumers, to actually be able to utilize the information, actually make value of it? So one of the things my team does in Microsoft Research is we look at how we can do new ways of kind of analyzing and communicating data and allow people to get access to it. So one of the things that kind of has come out of some of the work we've done is we've been working with Jeff Dozier from UC Santa Barbara on some of the hydrology work that he's been doing. And this is an example of another project we had done, which is called the fourth paradigm. How does you start bringing data sets together from different levels, different scales, both remote sensing, local sensing, and actually be able to make sense of it? So we're continuing forward a project with Jeff, actually looking at how you can actually take the knowledge they've learned and the algorithms for using remote sensing data in a place like California, which is actually better censored than places like Afghanistan, which only has 1 or 2 sensors. And in fact, most of those aren't working because they've been taken out by forces there. So can we use some of the same things, verifying them in California, and can we help them on some of the processing and different algorithms and ways to look at it? So one of the things I always kind of want to make sure set the ground on is when I think about data just in general is the slide that I got from Ilya, and really liked how it was laid out, that the raw data and the collection of that is really hard, but the value of that data becomes even more valuable as you go up the processing ladder. It becomes more valuable because it becomes more science ready and you can actually utilize it, hopefully more quickly. And so we've been also looking at that. How do you make data available for others? And even what Dan said earlier about a sustainable model for some of these data sets and services, we've been looking at that as well. How can we help scientists create a sustainable model for their work and not just have it be kind of relying on funding all the time? So we're trying some new ideas out in that space as well. First, I want to kind of talk about something that I always like bringing up, because I always like taking a step back on what are some of the real challenges we're looking at here. And we're all trying to find out the knowledge and actually have something happen, maybe a policy type decision or a change of behavior or something in those spaces. And so you want to get the knowledge from the actual system, so in this case, maybe Earth or the environment, and you want to inform the folks on the right-hand side, decision makers or just the general public. And so how do you do some of that informing of them? And so we've looked at, the kind of life cycle of a lot of this, and we're all familiar with this on the left-hand side. Data collection, data management, do some analysis, you get some, you do a really human portion, which is you gain insight from that data, and you actually want to then publish that or communicate that to others. And you really want to inform a lot of times on the right-hand side, they're the action side, the decision makers or the policy makers, something that will result in either a change of behavior or how things are going to be done. And those could be the general public or companies or even government agencies. And so we've been looking at how that interaction can work and where some of those challenges are. And so some of the things that we all have been talking about here, but also Dan mentioned as well, publishing the data, publishing maybe the algorithms around it, how do you get that? But one of the other things that's really key that we found in some of this work is making that data available to the decision makers and even the general public, making that real data available and not like a subset of it, actually increases the value and actually the confidence of what you're trying to tell people. So instead of it just being a video or a paper, how can you put it in a way that actually communicates the ideas across that boundary? So essentially, crossing the chasm in this area. And being able to actually have them make an informed decision on it. The challenge on this is that on that right-hand side, they get bombarded by information from many different sources, and in fact, much more sophisticated methodologies of getting the information out than most scientists actually communicate their information. So how do you take some of that same knowledge and understanding and use that to communicate? So, and this is where we think, obviously, that technology can help, and we look at ways to do that. So one of the other key things we think about a lot and look at is the whole idea of what we call discoverability, accessibility, and consumability. So I can find the data, I actually can get access to it, and I can do something with it, but you know what? Can I actually do anything with it once I have it? That's where that science-ready information and data comes in really handy. And what are some of the tool sets that wide, vast, consumers of the information, and how can they use it? So we have some projects going on. One of them in our Cambridge lab. We have some environmental scientists there, computational scientists. We have a project called Fetch Climate, which is how do we bring together a lot of the climate information into one area, be able to do a query on it based off of a graphical representation, and actually have the system look at the data sets and decide which ones are best based on the uncertainty of the different data sets. So that depending on what the query is you're asking for, you're actually querying essentially across all the data sets and getting the results back of the ones that should be the best for it. And so we look at a lot of these different ones to say, how can this help? And actually the URL there is live and people can try it out. We're actually working on a new version, getting it out as well. And we've also put in an API so you can query against it. So it doesn't just have to be a graphical interface, but can actually be a interactive program. Some of the learnings we did from this other project, Worldwide Telescope, which was about how do we get information from all the astronomy different data sets, all the telescope information, and make that accessible to other people. And so this has kind of resulted in not just a interactive way of roaming around the galaxy and the solar system and seeing all the different data sets. It was nice and challenging for us on the technology side because of issues like, how do you deal with different coordinate systems and how do you actually jump in between them and actually transfer information. But how do you make that really seamless so people don't care where the data is coming from, essentially? But then still have the ability to have the provenance to be able to know where the data did come from. And so we've been doing a lot in this space as well, but it's actually been used beyond that, and we've been working with it with different data sets on Earth and some of the other ones. But one of the things that really was key of the work we did, and this started 5 years ago, one of the key pieces we released was this idea of tours. And the idea of the tour was a way to share the information and actually be able to have somebody follow through with, could be narrated, could be just audio, could be much more multimedia kind of interaction, and then be able to pause, essentially stop it at any point, and be able to keep diving into it, look at the data. So let that learning go where you go at a low level, and then at certain points you want to dive in deep. And this is a difference between kind of videos and some of the others where you're on a linear progression and that's all you get. So how do you do this in a way that brings in multimedia and some of the other newer technologies as well? So we've been looking at that and also trying to see how we can apply it to earth sciences as well. We work with planetariums. The folks down at the Cal Academy used it in a show there around earthquakes. And we started looking at different types of visualizations of data sets. Again, more just for us to understand how it could be used, and would this help scientists communicate their data. So in the bottom left is the one about the, it's the model of one of the, it's a model output from the plane of where the quake would be. So they're trying to match up actually earthquakes themselves against actually the model output to see if it'll be correct. So we kind of been trying to figure out different types of visualization and how can we take advantage of a lot of the processing power that we have in a lot of the devices around. We've also made ways to actually share out some of the stuff through a thing called Layerscape. We wanted to actually have a way to create these tours and allow people to share them so that it was an easier way to interact with it. And we also looked at that kind of piece on how do we get to the making it easier for people to get to the data and actually put theirs in. And so we use things like Excel to be able to very quickly publish it in there. And we've done some other parts on, one of my guys actually has a piece of code that will allow you to actually publish it and do some higher level features beyond what Excel will let you do. And for us, this has been really interesting because one of the things in research is you want to actually see your work actually be used more widely. And one of the product groups, Excel, actually had seen some of the work we had done and actually then have just kind of been working on the tech transfer of it into a thing called Power Map. And so a lot of the kind of ideas that we were exploring within Worldwide Telescope has kind of put itself into this thing called Power Map, which is available for Excel. And now you can have people actually create some of these tours and these overlays with 3D data and actually hopefully unlock new insights within the data sets. So we get excited about things like that because it's you don't always have that happen. We also started this we just did last week. We have a tool called SQL Server Data Mining Tools for Excel. It's been out for 8 years. Most people probably don't even know about it. But what it had been is a way to actually take a lot of the tools and the machine learning that we had done within research and actually push it out in a way that could be more usable. And so there's these add-ins available. There's a whole bunch of pieces that you can do on the right-hand side that you can use directly. And what we did was we tied it to the Power Map to go, could we do some predictive predictive time series calculations based off of this is census data from 1990s, and actually then map it based on there. We're looking at the differences of the population growth, but one of the things is it kind of changes how you're interacting with, again, the data, and you can do it very easily from that kind of interaction. So we keep trying to figure out where is the sweet spot of actually this interaction with data, letting people use it, query against it, but actually be able to gain insights out of it. And these I'll just kind of skip through since most of all of us here know about them, about the data flood, getting the data sets from many different types of areas, from sensors, from historical imagery, from model output. How do we bring all this together? And really it's about the scale of these data sets and how do you do it on this a spatial and temporal way of bringing these data sets together at the different scales that they're all coming about, and may actually have it actually mean something as well. And so we've been looking at these as well. By the way, you see my nice little animations, one of the few times I actually do things. So why is this kind of important? It's really, for us, it's at the part on the bottom. We kind of believe that the science really happens when you start bringing together all these different data sets on the different sizes and actually kind of essentially mash them up. But be able to do it simply and actually be able to do it, have the experts actually be able to do it as well. So one of them that we started off, this was a number of years ago, and we're actually continuing it on in a new version, this Azure Modus project, which is actually looking at how can we bring in the data sets directly from the sources, process those in a cloud type system, so in this case Azure, and be able to actually run the whole pipeline and allow the scientist to actually do bigger processing than he could have done locally. So this is something we've been doing with Young Rel. He's now in Korea, and we're actually doing a new version of it to see if there's some new insights that we can get based off the work he's been doing on looking at new ways of processing it for the evapotranspiration. But it's kind of an interesting way going, can we move it from a single machine that he was doing to a large kind of infrastructure, and what actually needs to be there to actually have that happen easily. We've also been looking at what does it mean for existing kind of systems as well that are already out there. And one of my team members, Wen Ming, had done this in the past, where he took WARF essentially and runs it within Azure, and there's that URL, the Weather Service Cloud API, Cloud App, and allows, again, anyone to actually run the model over a specific area. And it'll give a detailed output based on precipitation, snow, temperatures, some of those. And as you'll see, and we actually have been processing this for a couple of years, and actually no one maintains it now. It just runs. So you end up seeing, like on the left-hand side, we have a kind of a map of all the ones that have been processed over time. There's output of the imagery. So you can see in that case, I think it's the temperature. And on the right, the different types of galleries. But again, making it very easily. And we know actually how much time it takes for each one of these runs, and essentially what the cost of that is to run each one of them. So it's interesting to go, this changes some of the thinking on, well, if I'm going to do this on demand on a certain thing, what is that as a commodity type price, right? To run a weather model for a certain area for a certain amount of time, what would that cost? We also allow it to, here's the end up being the kind of the architecture. Again, it's a simple one, pulling down the data sources from NOAA, processing those within within our HPC app that's out there, and storing them away. So again, how quickly and easily can you do some of these activities? The interesting part is it allowed us to actually scale up. By using some of the services in there, we can very quickly scale up. So if we want to do more, less, we can actually scale the number of nodes that we're running on. But again, not actually having to provision those in a really hard way. So one of the things that why we kind of been looking at Azure as well for some of these projects is because of the support for a lot of the different activities and everything from the different languages, virtual machines, but also different data management. So we've been looking, how can that be used? Can we use the Linux VMs for projects that need that? Can we use Python, where folks want to use Python code for quick, rapid application development? And what can we do? So this has led to this overall activity that we just actually started last week that may be of interest to this group as well, which is allowing essentially partnering with people and bringing some of this work to researchers and scientists. So we have a program, Azure for Research, where we actually have cycles available for folks to utilize. So there's an RFP out there. It'll be evaluated every 2 months, as opposed to some of the longer term ones that both NSF and others have. But we're looking for interesting projects could benefit from and looking at their applications and their science differently. And where can some of this actually happen that'll make it much more accessible to others? So can they make it much more accessible to other users? Can they actually come up with new ways to do this and actually try things at different scales as well? So it's something we just kind of started up, actually as it happens, we're doing some training here on another part of UW, specifically around this program as well. So whole new curriculum based on how you actually use this in a scientific area. And we've been working with a number of folks over the years, or actually over this last year, how to actually do that. So that's the kind of quick things I wanted to cover, and then I wanted to get Mohamed up to actually cover some of the projects that he's also been involved with. So Mohamed and I have actually been working together for the last 2-3 years, I guess, in different ways. And not only on the spatial side, but actually on some of the other activities he's been doing with actually universities here, UW and Bothell and Tacoma and some of the other ones on bringing some of the spatial work. So.
Can we get the audio as well?
As we are transitioning, any questions for Dan?
Yes.
So,
I'm not
Dan,
positive that the
if
audio
you're
is gonna
working
work.
as a
Technology again.
overlay competition for last 2 years.
I can bring the mic
So it's
closer if
ending now
needed, yeah.
officially.
Mhm.
So the your access also is expiring. So is this the program that you're thinking about where we can?
Yes, it definitely could.
Yeah.
Yep. Yep. So it would be a
Sorry.
place, and also just contact me about some of these as well. We're looking at different types of activities, everything from the grantings of it, but also visiting researchers, things along those lines as well. So we have some of those programs also spinning up, and so we're interested in folks that would like to come for weeks, months, to actually investigate and try some of these out as well. The other part I always kind of think about too is I have behind me in Microsoft Research, I have about 900 researchers focusing across the board on many different technologies. So everything from machine learning to image processing, hardware devices, things like that. And so
Sending it again?
while I try to keep track of them all, having folks actually come and visit and actually drive those conversations, one of the things we look at is how can the technology be essentially transferred to scientists or others, because some of the work will never be used in products, but some of the ideas can be used in other areas. And so this was based off of a lot of the work that, or previous work that Jim Gray had done on working with groups and trying different ideas out. And sometimes we come up with good solutions, sometimes we may not. But if it can move the science forward, that's good for everyone. So,
Is it either or?
No, it shouldn't.
any other questions? Sir?
Yes. The data mining tools for Excel, is that still, being developed or it's already available?
It's already available. So it's been out, like I mentioned, for 8 years. And it's kind of hidden away. The best thing to do is do, I'll say it, a Bing search, in case you guys don't know about that. Nice search.
Is that a verb? Just Bing that?
You can Bing it. But if you look for SQL data mining tools or Excel add-in, you'll find them. And they just updated it for the Excel 2013.
Is that free download?
Yep, it's a free download.
Okay.
Yep.
We just add to the Excel, add-ons, right?
Yep, it's an add-in to Excel and allows you to do some of that work as well. So
So for the data, we prepare the data, say latitude, longitude, and some, variables, right?
right.
It's a
So
picture.
so to get it into the Power Map, you end up having things like the latitude, longitude, and those. Natively, the data mining tools don't care what the columns are. It's actually just going to look at them for whatever you specify. So if you want, as I kind of mentioned, there's a whole bunch of other, if you want correlations or if you want some other analysis of them.
So you can give some 3D dynamic, illustration.
Right, and if you specifically want to do that, feel free to contact me because I'd be glad to. Actually, Carl, one of the guys working on it, our SDEs, sits right next to me, and so we've been actually. He's been playing with it in different ways, going, okay, sometimes you don't have to create something new. Sometimes it's just pulling things together. So,
Okay. Wonderful.
yeah.
Can I give you that back?
Okay, great.
And maybe I'll move you
Okay.
over this way. So. Yeah, go ahead.
Okay. Dan, really, as always, I really appreciate your talks, and I appreciated the emphasis on cloud computing, because I don't think that's something that we discuss as much here at CyberGIS. Not that clouds are to replace supercomputers or other types of infrastructure, but I'm wondering, given your advancements in cloud computing, which is something that we're very focused on at Esri as well, could you comment for the group here in terms of how you're finding things such as processing speed, server loads, capacities, and security for clouds?
Yep, sure. So, let me try talking to the mic, I guess.
It
So-
doesn't.
Oh, it doesn't?
It's fine at
Okay.
this point. Thank you.
So one of the things we look at within that, and what we have found, is we're building off of the infrastructure. So on the security side, we're building off the same infrastructure that the company is using for other companies. And so there's an implied use of security within those. So we kind of leverage that. Plus there's other work they've done on making it HIPAA compliant and some of the other ones. So we gain a lot of ability on that. So the security in those I'm not too worried about. There's also an interesting model that we look at within cloud, which is, as a company we look at, which is a hybrid model, which allows you to have data maybe locally on your own site, use the scale-out processing of the something like cloud or Azure in these cases, the nodes, and actually be able to feel secure that the data is still local, or move it up when you need to. So it's not a all or nothing. It's one of those where you can try some of the things, and this is what we're seeing on the, I'll say more on the business side and the corporations. They do a little of both of those. Most people never start with a brand new project. They're always kind of incrementally changing, going from working to working. On the processing speeds, the challenge is you're never going to be as fast as actually a local machine with like a supercomputer or HPC cluster. And a lot of the cloud apps or processing can use a lot more nodes, so you're not actually at a, you can keep bursting out to more and more nodes, let's put it that way. And in fact, what we have some clients do is use a local node cluster and then you burst out to the cloud for actually even more processing power. So when you need to go above what you can do, use that. You can run HPC type apps on it. Not actually, you never get the performance you get locally because you're dealing with virtual machines and virtual networks. But the thing you do get is triple redundancy on storage. The geospatial. And you don't pay for that. It's just inherent in these systems. You can also geo-replicate the data. You can geo-replicate the processing as well. So I think I got most of your answer. So. Great. I'll turn it over to Mohamed.
You want to check the audio, and you don't have to worry, we're no longer in the meeting room
Okay.
because you're doing a live demo.
We'll figure out as we go, you know?
Yeah.
Technology is never predictable. Yeah. Okay, so I think I started part of the story yesterday when I was complaining and, you know, carrying over my frustration of how our shipping cycle went from 5 years all the way down to 3 months, which gives no room for someone like me to do some research and then try to ship this research as a nice product. And as I mentioned yesterday, I think that this may be the only possible way to ship something innovative is to engage in research with smart professors like you. But because professors are totally unpredictable, the same way technology is unpredictable, the same way our shipping cycle is unpredictable. So I decided to do something else. So I decided, okay, let me try it myself one time. So I decided to roll up my sleeves, go to the UW, and that was actually at the UW. I started at Tacoma Institute of Technology over there, and okay, I went into a classroom, kicked out the professor, and said, okay, I'll be teaching the GIS class myself. I'm gonna be hijacking your students and I'm gonna force them to do something that I believe of value to both research, industry and academia and everyone else, okay? And the story started whenever I was invited to give a talk in an orientation for the new grad students. So I was driving from my office in Microsoft in downtown Bellevue, going all the way to Tacoma, which is 40 minutes with no traffic, 2-3 hours with traffic, okay? So while I'm driving, yes, I was frustrated because of the traffic, but I was thinking all the time what I should be saying during the talk. So that was the only opportunity I could prepare for the talk while driving. So while I was going out from the Microsoft campus, I figured out there is a lot of traffic around the Microsoft buildings. And I was frustrated on one side, but I said, okay, because there is a lot of traffic around Microsoft, there must be something valuable in Microsoft. So there must be, I must be doing something good because, you know, lots of people are heading to Microsoft. But as I'm driving on the highway, you know, the traffic started to clear up and all the traffic was on the other side, on the other direction. I was happy on one side, but again, I said, because everyone is headed in this direction and I'm going the other way, I must be doing something wrong. So, but till I came closer to the UW campus, traffic started to build up again, which means there is something useful going on around Microsoft, something useful going around the UW. And the question was, why there is no traffic in between? That was the question. If you want to be pessimistic, no one can make you optimistic. And I'm always pessimistic. Here is traffic, here is traffic. So why it was clear in between? So the question is, can we increase the traffic between industry and between academia? Can we make sure that the communication between industry and academia is going in the right direction? And that was the key goal teaching a class at the UW. I said to the students, we have to make a project that I can make a product out of it. We want to make sure that you are not just, making a project like, you want to go to the moon or you want to go something like this. If you are shooting for a project, I can take this project, make a case, and ship it as a product. So they started dreaming. Overnight, everyone is coming up with a suggestion. I found the best way to lead a successful project with students at the UW is to tell them, hey folks, don't tell me your ideas. I am gonna connect you with someone, you have to make him happy. So I am going to connect you with one of our customers. We are, as Microsoft, we consider ourselves technology producers. I am going to connect you with a company that is technology consumer for our products. Make him happy. I connected the students with a company called BI. They are building software for the government. So now we are leading a project between Microsoft as a technology producer, between BI, which is a technology consumer, building something for the government, and whoever is gluing everything together is the university, the UW, academia. So what I'm going to do right now is I'm going to run 3 videos. There is one take-home message behind every video. Okay, so I'll start with the first video, fast forward every now and then till we come to the most useful places of the video. Now, let's see technology, how technology would work in this.
This is the Geos.
Okay,
An idea.
attempt number 1 failed.
What was it?
Okay,
This is the Geospatial criminal tracker demo.
bring mine.
Hold on just a second.
Convicted offenders, as well as suspects awaiting trial, are frequently required to wear ankle bracelet monitors.
I don't know.
A centralized tracking system for these monitors
Is this
needs to
HDMI?
handle large amounts of
It's
incoming
different.
data and must be alerted to unwanted
So you
behavior,
pause it for a
such as
second?
offenders entering.
So I think
Yeah, I
what
think
we're
this
trying
one,
to do
yes.
is figure out how to get this computer audio using these speakers. That's our
Making these
issue.
determinations require resources and judgment
There we go.
that must be
Okay.
performed at the time of the event. Automating these decisions will greatly benefit law enforcement, allowing
So those are my students.
Geospatial criminal tracker demo. Convicted offenders, as well as suspects awaiting trial, are frequently required to wear ankle bracelet monitors. A centralized tracking system for these monitors needs to handle large amounts of incoming data and must be alerted to unwanted behavior, such as offenders entering prohibited locations or being physically present with other offenders or protected targets. Making these determinations require resources and judgment that must be performed at the time of the event. Automating these decisions will greatly benefit law enforcement, allowing relatively few monitors for several tracked targets.
So that was experience working with students and working with criminals as well. So what happens is the government track criminals by putting ankle bracelets around their ankles. So as they are moving around, they are tracked all the time. Their GPS location is streamed. So what we want to do is we want to figure out when a criminal enters a restricted zone. That was one of the queries, simple query, but we want to answer this query. We want to figure out, do we have 2 criminals who are being tracked at the same system? Are they coming closer to each other? Do they meet up frequently? Are they planning to do something? Can we keep analyzing their behavior? If a criminal is circulating around a school zone, what is the probability that he's going to break into this school zone? So let me fast forward a little bit.
show the results of such data. The criminal tracker can list real-time activity of criminal triggering a restricted zone alert. These are used to give an overview of the easily extendable, as well as the variety of static data that can be employed. This is the Geospatial Criminal Tracker user interface. In this demo, simulated GPS traces are used to give an overview of the system. In the left column, a stream displays alerts in real time as they are pushed from Stream Insight. An alert can occur when a criminal enters an area that is restricted to him, triggering a restricted zone alert. Or a proximity alert can occur when multiple criminals gather too close to one another. On the right-hand column is a map that displays real-time activity of criminals and restricted zones. Currently, there are 3 restricted zones displayed, all of which are areas 2 criminals cannot go. These static areas are stored in the database and pushed to the user interface to be displayed on the map. These are the same areas that are used to calculate the occurrence of an alert. The 2 criminals are represented as points, and locations are updated in real time as their locations change. Criminal 10 is the bottom point, and criminal 20 is the top point. These locations are also pushed from Stream Insight. At the beginning of the scenario, both criminals begin heading towards the restricted zones. Criminal 10 triggers a restricted zone violation when he enters UW1, and soon after, Criminal 20 triggers another restricted zone violation when he enters the library. We'll now move on to the next portion of the demo.
Okay, so that was UW campus at Basel. You hear the word Stream Insight many times. So this is a project that was born at Microsoft Research, and I was privileged to get this project and incubate it on the product side of Microsoft. The main take-home message from this video is we would be interested in working with researchers, working with academia to some kind of glue our products as producers of technology with some consumers, maybe other industry companies, maybe the government or someone else, and we get someone solve the interesting technical problems in between. So the second video I'm gonna show right now, this is a super exciting video. Did you see that one before?
The Intelligent Transportation Project, developed by Integrated Media Systems Centers at USC, collects and stores and analyzes transportation sensor data from Los Angeles County road networks. This project is a collaborative effort between government, academia, and industry. IMSC has been working with the Los Angeles Metropolitan Transportation Authority for the past several years to collect and archive the road network sensor data using Microsoft tools. The traffic data types received from RITS, Regional Integrated Intelligent Transportation System, range from highway, arterial, bus and train GPS, to ramp, meter, events, and CMS. Microsoft Stream Insight acquires and processes these data sets using input and output adapters. SI includes 1 input adapter for each data type and 2 output adapters to store the data in a cloud storage system, Windows Azure, and a local database server. On average, the system processes around 15 terabytes of data per year. Since 2010, the Clever Transportation Project at USC depicts traffic data for both highway and arterial data vectors in Los Angeles County on a big map. Scattered across 3,000 square miles, 6,500 large-scale and high-resolution traffic sensors relay information back to IMSC servers. The dataset includes real-time data at a sampling rate of 1 minute. However, for demo purposes, the data map is updated every 5 seconds. Each data point indicates the current speed of that sensor with a color code. Here is a highway map of Los Angeles with 2,000 sensors scattered across all the freeways. Data regarding speed, volume, and capacity are collected. Color codes indicate red as slower traffic and green as no traffic at all. Stream Insight input adapters receive data from RITS and run continuous queries outputting the results to graphs. We define a query once, and as the data comes in, the results are updated accordingly. On the right-hand side, there are 3 graphs representing the data. The uppermost graph shows the average speed of all the sensors in the last 60 minutes. In addition, it is possible to select a variable range for both space and time.
Okay, so in this project, all the highways of the LA County, it was monitored and the data was pushed through some input adapter. The nice thing about this project, it is a collection of, or a stack of Microsoft technologies blended with nice researchy algorithms over here. So as I mentioned yesterday, whenever we are training our salesmen, we are not selling a product, we are selling a stack of products. So here you can find, the data is being streamed using Stream Insight. It is a tool for collecting, processing data at real time. Then data lands in Windows Azure, it becomes in the cloud. You can use SQL Server to do further analytics. You can use some kind of Bing Maps or Bing Tools, Bing Analytics for further processing. So what I really liked about this project is we managed to get everything, all our tools, then use them in a new way that we've never thought of before. So thanks to the students of Cyrus for this project. So one final quick video I'm gonna show right now. This is another new demo.
Extensibility approach for spatiotemporal stream processing using Microsoft Stream Insight. My name is Jeremiah Miller. In this demo track paper published in Advances in Spatial and Temporal Databases, 2011, my co-authors and I present a scenario where a number of mobile devices, such as smartphones, stream their current geographic locations to a server that performs real-time spatial queries on this data stream.
Okay, so for the sake of time, what happened is we gave the students few Windows phones, smartphones, and we said, okay, so what we want to do is we want to build a phone app. This phone app will be collecting your GPS locations all the time as you are moving. And on the server side, we want to build the next generation of spatio-temporal data stream systems. Can you take a data streaming system? Can you take SQL Server and Stream Insight? Those are all coming from the SQL Server division, from the database division. Use the SQL Spatial library. Take everything, blend them together, give us a full-fledged spatio-temporal data streaming system. So here the main idea behind this system is we are not just building an application or building a feature. No, we are shooting for a full-fledged system that students or researchers in the future can come, plug in different modules. As we go in time, we can end up having a bigger and bigger system. So what these students have done, they took these technologies, they started to build a layer to wrap everything together under one umbrella, add new spatio-temporal operator, and this is the scenario that they have been addressing. I'm gonna fast forward a little bit.
Operator, which updates a spatial index, not match the spatial query parameters.
So this is the Windows Phone side, this is the server side.
The Silverlight app responsible for controlling the server and displaying the query results. The red place marker is the location of the query phone, which is the phone whose screen is shown on the right side of this video. Blue and orange place markers show the locations of other phones. Orange place markers are those phones that match the spatial query criteria, and blue place markers are the phones that do not match the criteria. The blue phones are only shown for the sake of demonstration. A deployed solution would have no need to output these non-matches. As the phones run for a while, we can see their place markers move as they acquire more GPS satellites. This causes the positions of some of the phones to fall inside the query parameters and turn orange. To help illustrate that the UDO is operating correctly, we show a dark gray box around the query phone on the desktop output adapter on the left. This is the outer boundary of the query range. If the solution is working correctly, any device should turn orange if it goes inside the box and blue when it leaves. Now, my co-author, Miles, takes one of the phones out the front door and wanders up and down the street. I take two of the other phones out to the alley.
Wow.
As you can see, the phones are now mostly outside the query range. In this part of the demo, we show the solution working with real
Okay, so the students, you were just, some kind of wanted to get some of our phones and started playing with the phones, but they deliver something very interesting. I will see that this can be the seed of a full-fledged spatio-temporal system. And again, this is what we're looking for in collaboration. We are looking for someone who is willing to connect technology producers with consumers. We are looking for someone who can blend all the various technologies we are producing, and finally someone who can build a system that we researchers, others can build on top of this, keep extending this one, and it can keep advancing as we go in the future. And I think this is all what I have for today.
Great.
Questions?